Hey guys, just before I start this video, I needed to clear up a small error I made in the previous video. For beta equals a half, the UB of time 2, there's a half out the front of this part. I do not include that half, but there's a half out the front. So the objective of this video is we're going to see how to march a solution forward when beta equals a half and when beta doesn't equal a half. So we've got here a layer of soil which we've subdivided into three layers, 1 meter, 2 meter, and 3 meter. And we saw in the previous video we have the time, the applied stress. I've included now the change in applied stress from time 1 to time 2 and all the pore water pressures at a certain time. So I'm just going to quickly fill in some values. We can see that at time 2 the change in stress will be Q2 minus Q1, so we might get a change in stress, and we're going to fill in values now. So we saw in the previous video these formulas, so I'm just going to explain what they mean now. So if we wanted to find a excess pore water pressure at time 2, we call that UB. UA and C, so A is obviously above and C would be below. So UA of time 1 and UC of time 1. Okay, so UB is between A and C, and they're separated by time 1 and time 2, which are previous time 1s and times 2s. The same thing applies here. If this was UB times, if I want to find this value, it would be UA of time 1 and UC of time 1. Okay, so UB, UA, UC, and time 1 and time 2 are not, they're not restricted to a particular value. They move around. Okay, just know that the A's and C's are above and below, and the previous times are before are above and below. And this can also be marched forward for as many columns as you want. So we're just going to do quick examples to demonstrate what I mean. So if we were to do for beta equals a half first. So we saw the formula for beta equals a half is UB at time 2. So the next solution is the change in stress plus the U plus 1/2 outside of the UA of time 1 plus UC of time 1. Okay, so that's how we're going to march a solution forward. So if I were to just do a quick example to show you what I mean. So we have time Q, the change in stress, Z equals 0, Z equals 1, Z equals 2, Z equals 3, and that should be enough. So say we're looking at 2 years and 3 year. Say the applied stress is 100. So this is like just like the previous video where the stress was not changing. So we saw this in the previous video here. The stress was not changing at any point. So it's a consistent 100 kPa, which means that at year 3, the change in stress will be 0. It's 100 minus 100. We would have some boundary conditions which I'm just going to make up. So say these are both 0 and 0 down the bottom over there. So let's just rule this off. Okay, and I'm just going to make up some values now. So say this was 40 and this was 100. So if we wanted to find UB for beta equals a half, we're going to use this formula. So UB, so the blue UB would equal the change in stress, which is 0, plus 1/2 of UA in time 1, so that would be that value. So 0 plus UC of time 1, so the previous time, which would be 100. Okay, and we will work this out. So 0 plus 100 is 100, divided by 2 is 50. So this value would be 50 kPa. Now I could find this value as well. UB, so that's also UB. So UB would equal the change in stress, so that's 0, plus 1/2 outside of UA of time 1 would now be that value, so 40, plus UC would now be that value, which is 0. So this would equal 20. Okay, so this value is now 20. I could also continue this on further, where these values would now be UA and UC, and the UB would be in the next column. Okay, so this is just a quick example to show you how to march it forward, and this is only for when beta equals a half. So I'm just going to quickly show you now when beta doesn't equal a half. In most cases, beta will equal a half. It's stupid to make beta not equal a half. You would never actually do it. In most cases, beta would always equal a half. So just, you're going to have to know that formula quite well. If I were to do an example just to show you in case you were to get a question, which I doubt you would, when beta does not equal a half, you still need to know how to do it. So the formula is UB of time 2, so that the pore water pressure in the future would equal UB of time 1 plus the beta outside of UA time 1 plus UC time 1 minus 2 lots of UB time 1, that's all times by beta, and then we also need to add on the change in stress. So if we were to just do a similar example to the one we did before, and let's say in our case the beta equals a third. So let's have time applied stress, the change in stress, Z equals 0, Z equals 1, Z equals 2, and Z equals 3. So let's say we had a very similar example. So we have 2 years and 3 years. Let's say that the stress is also 100 and 100, and that is obviously not going to change. So 100 minus 100 is 0. Let's say that that value was 0, that was 0, this is 40, and this is 100. Okay, so it's the exact same case as before. So let's go ahead and find, and just based on boundary conditions, that'll be 0 and 0. Don't worry so much about how I got those values. We're going to see in the next video how we do that. But if I wanted to find UB, so UB would equal the UB of time 1, which is this value, so 40, plus my beta, which I've defined as a third, so a third, outside of UA of time 1, so that's that value, plus UC of time 1, so that's that value, minus 2 lots of UB of time 1, so that's back to that value, so minus 2 lots of 40, and this is all plus the change in stress, and the change in stress is 0. So this would equal 100 minus 80 times by 1/3 plus 40, so 46.7. So this is 46.7. If I now want to find this UB, that would equal the UB of time 1, so that would be there, so 100, plus the beta, so 1/3, outside of UB, so UA of time 1, so in this case it's now that value, so this one, so 40, plus the UC of time 1, so UC is now that value, so that's plus 0, minus 2 lots of the UB of time 1, so that would be this value again, so minus 2 lots of 100, plus the change in stress, which is still 0. So if we were to work this out, we get 40 minus 2 outside of 100 times by 1/3 plus 100, so we get 46.7. Okay, let's just double check that. 40 minus 2 lots of 100 times by 1/3 plus 100 is 46.7. Okay, so don't worry so much about the numbers, just understand the process of how we march a solution from one point to another point, and that is dependent, the formula we use is dependent on whether b equals a half or whether b does not equal a half. We use this formula. Okay. In the next couple of videos, we're going to be doing examples using all the principles we've developed so far to come up with a numerical solution which has many columns. But just understand now how we march the solution forward. Anyway, guys, hope that helps.